Pawan Prasad from Samsung R&D Institute, India, Bangalore. The title of my presentation is Burst Reflection Removal using Reflection Motion Aggregation Cues. Reflections are common when you try to capture images through an obstruction such as glass. Removing such unwanted reflections turns out to be very challenging as it is severely ill-posed. The output image is typically modeled as a linear combination of two layers, namely the desirable transmission layer and the unwanted reflection layer. State-of-the-art methods use different types of cues such as ghosting cues, motion cues, etc. to make the problem more tractable. Let's look at the challenges in existing reflection removal methods. The single image methods are severely ill-posed and require some sort of prior information of the scene. More recently, there has been only small incremental improvements over the state-of-the-art. Most of these methods are highly complex. On the other hand, the multi-image methods are less ill-posed, but they are inconvenient for a typical user as is expected to capture from multiple viewpoints as shown here. Our methods, however, tries to capture a burst of images, and by relying on small handshakes, we extract discriminating cues that help in removing reflections. We first explain the proposed motion aggregation cue. Let's take a simple toy example as shown here, where the triangle represents the desired transmission layer and the donut represents the unwanted reflections. We use a burst of images to generate a cue that de-emphasizes the reflection layer more than the transmission layer as shown here. This discrimination is exploited in a later stage to recover the desired transmission layer. The proposed multi-stage architecture is shown here. We initially perform pre-processing on the input burst, which suppresses reflection individually on each image. The reflection suppressed images are then aligned spatially and blended to generate the reflection motion aggregation cue. This cue is later utilized to guide the reflection removal. The cue generation stage and the guided reflection removal stages are first trained independently, followed by end-to-end training. We apply a synthetic motion model to the aligned burst frames to generate small misalignments to the inputs during training. This training strategy helps in handling misalignment errors caused due to incorrect homography estimation. We use a combination of pixel loss and contextual loss to learn different stages of our pipeline. The pixel loss is a combination of L1, L2 and gradient L1 losses, while the contextual loss uses a VGG backend that helps to learn in presence of spatial misalignments. We first show the results on the burst image dataset and compare against the latest state-of-the-art methods. Our single image based methods, one single image based methods and two multi-image based methods. It is evident that our single image based method cannot handle these kind of strong reflections. However, our method is able to beat the latest multi-image methods as well. We next evaluate on the publicly available large baseline dataset. Our method is able to remove reflections much better than the state of the art with minimum artifacts, where some of the existing methods introduce artifacts as evident in rows 2 and 3. We next demonstrate the quantitative evaluation on 3 different datasets. Our method is superior on 2 datasets and second best on the large baseline dataset. The best performing method on the large baseline dataset is an iterative approach that is about 2500x slower than our method. To conclude, we propose a novel method for removing reflections using a burst capture where a novel reflection motion aggregation cue is proposed. Our method is superior to single image methods by 2 dB and multi-image methods by 1 dB on synthetic burst dataset, 1 dB on burst real dataset and 2 dB on the public large baseline dataset. Thank you.